welcome to today's lesson on laws of indices. So it's first worth thinking about what indices are. Now indices, in fact they demonstrate quite well in this first question, their powers and the ways of representing something as a power or an indice. So if we look at this first one here, we've got 3 times 3 times 3 times 3 times 3. It's probably worth getting this one down as an example. Remember, the only way to learn maths is to do it. So example 1. So this first one, only 1 mark. It is from a past paper question though. It's from the Edexcel paper actually. And we've got 3 times 3 times 3 times 3 times 3. Is that right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Good. So if I want to represent this as an indice, when I'm multiplying anything that's the same, whether it's 3, whether it's x, whether it's a, this is going to be equal to a power. So this is going to be equal to 3 to the power of 5. And I've put that first one in there just as a little example. You might already know that, but I just wanted to show you exactly what an indice was. So let's check that answer. 3 to the 5, brilliant. 1 mark for that. Brilliant, and we're off. So let's have a look at some of these questions here now. Now, this is our first law of indices, which says that when you're multiplying powers together, then you add them. So it's probably worth getting this down before actually. In fact, to get this example down, let's do example 2. And here we've got a to the power of 2 times by a to the power of 3. And what is that? It says simplify it. And what it's asking for is asking you to write it as a power or write it as an indice. Now, if you wanted to, you could do this. We know that a to the power of 2 or a squared is equal to a times a. Don't write this down for now. This is just an explanation. Times by a times a times a. Now, this is exactly the same pretty much as the one up there, but it's just in terms of a. So here I've got 1, 2, 3, 4, 5, all times together. So this is equal to a to the power of 5. Now, we're looking for a quick way to be able to do that. And you might notice that a to the power of 2 times by a to the power of 3, it's the same as adding both of those. So I can add both of those. So don't worry about getting that bottom bit down. Just get that top bit down. If you want to, you can call that the addition law. Probably worth writing this in your notes. So that's the addition law. You can write this down as a general rule if you want. I'll write that down for you now. So the general rule for this one would be that x to the power of, let's say, a times by x to the power of b is equal to x to the power of a plus b. So when you multiply two things together with the same base, now this is really important actually, it's probably worth thinking about this. This is called the base and this is called the power. Okay, so this is your base. Now they do have to have the same base, okay? Otherwise this doesn't work. So we're multiplying things with the same base, it's the same as just adding them. Okay, get that down in your notes as your first example. Okay, and then we're going to pause, and I want you to have a go at that one on the right hand side. So pause now and have a little go at that one. Okay, notice that this one does look a little bit strange because it's like, what's this x to the k? Where k is an integer. Now remember, an integer is just any whole number. So although they've wrote it like that, it's exactly the same question. So this one here is example 3, really easy, nice and straightforward. So 7 to the power of 2 times by 7, can't write today, times by 7 to the power of 5 is equal to, well, when I'm multiplying powers, I add them together, so that's 7 to the power of 7. Brilliant. So let's check those answers. Nice and straightforward, that. a to the power of 5, 7 to the power of 7. Super. Okay, so let's have a look at our next one here. Now, I've put this one in here as a kind of special case. If you think you know the answer, maybe have a go at it now. Okay, I'm going to go through it anyway. So this one here says Q times by q to the power of 5. Now you might think to yourself, this one here is example 4. Well, there's no power on that first one. Now, there is a power on it, it's just that we don't always write it. The power on that one, you might think that it's 0, but actually the power on that one is 1. It's a little bit like when you have like 1x or 1a. We don't write the 1 in front of it. We'd only just write x, and we'd only write a. And it's exactly the same with powers like that. So this is x to the power of 1 and a to the power of 1. So this one here, my first stage of this one is I'd probably put the power in. So q to the power of 1. And then it's exactly the same. So when I'm timesing powers with the same base, I add them. So that one there is going to be q to the power of 1 plus 5, which is 6. Nice and straightforward. So easy, that one. Okay. So let's just check the answer. Q to the power 6. Super. Okay. So let's have a look now at these. Now we're stepping up a little bit here. Example 5. Honestly, I still don't think this is that hard. This is a little bit different now. So this is y to the power of 5 divided by y to the power of 3. Get this one down in your notes, okay? Remember, the only way to learn maths is to do it. You need to get this nice and neat in your notes. Now, I'll show you the example first, and then I'll tell you what the rule is. Now, you don't need to do the example every time. I'm just showing you that so you know how to work out if you want to, but I wouldn't do this with everyone. So we know that y to the 5 is the same as saying y times y times y times y times y. Okay? All divided by y to the 3, which is y times y times y. Now with that, we can cancel these because we've got the same on the top and bottom. So we can cancel one of those y's. We can cancel another one of those y's. We can cancel another one. And we're just left with y times y, which is the same as saying y squared. Y to the power of 2. And that's because we're only left with 2. Now you don't need to do this with every single one, because this is just called the subtraction law. Okay, so here we've got the subtraction law, which says when we're dividing powers, we need to subtract. So y to the power of 5 divided by y to the power of 3 is the same as y to the power of 2. And you can do that for a general case if you want. I'll do the same, similar to the x's. So x to the power of a, so x to the power of anything, divided by x to the power of b is the same as saying x to the power of a minus b. Okay? So that's your second law there, your subtraction law. Okay, so pause now and have a little go at that question on the right-hand side. I think you'll fly through that. But pause now and have a little go at that one. Okay, I think you're probably flying through this. You might think it's too easy, but we will get harder, I promise. So with this one here, I've got q to the power of 5 divided by q to the power of 2, which is the same as 5 take away 2. In fact, it's very similar to the one there, isn't it? Which is going to be q to the power of 3. Nice and straightforward. Hopefully you smashed that. Well done if you did. Okay, let's move on. In fact, let's just check our answers. Y to the 2, q to the 3. Brilliant. So, let's have a look at this one now. Now, this is one of the ones that people tend to make the mistake with. This one here is example 7 now. Okay. Now, you've got to think about what these brackets mean. Brackets mean you're doing whatever it says to all of it inside that bracket. So here I've got k to the power of 3, all to the power of 2 there like that. Now this to the power of 2 means that anything inside that bracket is times by itself twice. Okay, so what this means is k to the power of 3 times by k to the power of 3. Okay. Now again, we don't need to write this. What we know, we can use the addition law to help us with this though, because k to the power of 3 times by k to the power of 3 is equal to k to the power of 6. Now you might think to yourself, well, all I need to do is to multiply those, and you'd be exactly right. I'm going to show you another example of this one, because I think this one here, although we've got it twice, I want to do another example just to make sure you understand it. So let's have a look at this one. Let's do A for Mr. Adams. So a to the power of 4, all to the power of 3. So this one here is telling us I want a to the 4 times by itself 3 times. 1, 2, 3. So this means a to the 4 times by a to the 4 times by a to the 4. Which I know is, we add the powers when we're timesing. So that's going to be a to the 4, sorry. So this one here is going to be equal to a to the power of 12. You might start to notice the pattern here. When I've got this one bracket here, so like something raised to the power, I multiply. This is the multiplication law. So I multiply these two. Look, 3 times 2 is 6. 4 times 3 is 12. So this one here, I'd probably suggest getting this one down in your notes actually. This is probably a better question to do. This one here is the multiplication law. This is the multiplication law. And I'll do another one similar to the general example. So if I've got x to the power of a, all raised to the power of b, I know I multiply those. So this is the same as saying x to the power of a times by b. Okay? So I times them together. And it's because it's going to be a to the 4 times by itself 3 times. So I get a to the 4 times by a to the 4 times by a to the 4 like that. Which is the same times in there. Okay, so pause now and have a little go at that one on the right hand side. Pause now and have a go at that one on the right. There. Okay, let's have a go at this one together. I think you should be fine with this. Now, with this one here, it says give it as a power of 4. A lot of people with this one here might just put it into the calculator. That would be wrong. You'd get no marks for that because you're actually working it out and it's not asking for that. It's asking for it as a power of 4. So with this one here, example 8, I've got 4 to the power of 6, all raised to the power of 3. Oops. 4 to the power of 6, all raised to the power of 3. This is the multiplication law, so I'm timesing those two numbers. So it's going to be 6, 12, 18, 6 times by 3. So it's 4 to the power of 18. And you do not work that out. It's asking it for it as a power of 4. Brilliant. Okay, so that's the 3 rules. And they're pretty much everything we're going to go through today. We're going to extend it and take it further. But if you know those and you can understand those, this does become easy. So let's just check those answers. There we go. K to the 6, 4 to the 18. Brilliant. So let's move on. Let's have a look now at some of these ones. So we are getting a little bit trickier here. And the reason we're getting a little bit trickier is because we've got more things to think about. We've got the division of the fraction and we've got the subtraction law because it's divide. So this one here is example 9. Brilliant. So here I've got 12 x to the power of 6, y to the power of 9, all divided by 4, x to the power of 6, y to the power of 3. Just like that. Now, the thing that makes this tricky, there's a few things that make this tricky. The first thing is that this here is just a division. It's 12 divided by 4. So you're not subtracting. These are actual whole numbers. So when I'm doing this, I have to do them in stages. You do the numbers first, then I'm going to do the x's, then I'm going to do the y's. Now, these don't have to be x and y's. They could be a's and b's, but in this one, they're x and y's. So first of all, whole numbers. What is 12 divided by 4? Well, 12 divided by 4 is 4, 8, 12. So that answer there is 3. Now, when you're doing division of powers, remember you subtract. So x to the 6 divided by x to the 6 is x to the 0. And actually, they just cancel out because that's everything on top divided by everything on bottom. So I've actually got no x's in there. Okay? And the last one, y to the 9 divided by y to the 3. Remember that we're subtracting. So 9 take away 3 is y to the power of 6. And that's all I'm left with. 12 divided by 4, I do the division. When I'm dealing with powers, I subtract. Be careful, because a lot of people here, they either divide these and say 9 divided by 3, which is 3, wrong. Or they subtract these, and that says divide. 12 divided by 4 isn't 8, 12 divided by 4 is 3. And this is where it starts to get a little bit trickier. Okay, so pause, make sure that's in your notes. Pause now and have a little go at that one on the right-hand side there. Pause now and have a little go at that one on the right. Okay, so let's look at this one together then. Very similar to the last one. Is it example 9, I think? Maybe, yeah, I think it's example 9. Example 9. Okay, so I've got 15 x to the power of 9, y to the power of 9, divided by 3 x to the power of 8, y to the power of 8. Okay, so let's deal with the numbers first. Remember, when I'm dealing with numbers, I'm just dividing. So what is 15 divided by 3? Well, 15 divided by 3 is 5. Brilliant. Okay. And here, when I'm doing powers, remember, powers are subtract. So x to the power of 9 divided by x to the power of 8. Well, it's going to be 9 take away 8, which is 1. So it's going to be x to the power of 1. But I don't write it. I could write it as x to the power of 1. You tend not to write it as x to the power of 1, remember, because I just write it as x. If you wrote x to the power of 1, you probably would get the marks, but it's better to just leave it as x. And it's exactly the same with this one, actually, isn't it? Y to the power of 9 divided by y to the power of 8. 9 take away 8 is y to the 1. I don't write y to the 1, I'm just going to write y like that. Brilliant. Super. So let's check those answers. 3y to the power of 6 and 5xy. Notice they haven't wrote the 1s on there. Brilliant. Super. So let's have a look at some trickier ones now. Okay, we're getting a little bit harder now. A little bit harder. Not that much harder. I think we should be able to nail these. Now, I'm going to suggest that you either do the multiplications or the top and bottom first. Simplify them so there's only one thing on top and bottom, and then subtract them at the end. So this one here is example 10. And it says 8 to the power of 2 times by 8 to the power of 17, all divided by 8 to the power of 5. And we want it in the form 8 to the power of k. We saw that at the beginning, didn't we? Okay, as an integer. So it's not asking you, this might come up with a calculator paper and then people just go and type it into the calculator, but actually they're asking you to work it out as a power. So the first thing I'm going to do, we've got 2 stages here. I'm going to do the top first, okay, and do the addition law, and then I'm going to do the bottom and do the subtraction law. So I'm going to write them underneath each other. This is the correct way to do things in maths. So the first thing to do, 8 to the power of 2 times by 8 to the power of 17. When I'm multiplying powers, I add. So this is going to be 8 to the power of 19, still divided by 8 to the power of 5. Brilliant. And remember, when I'm dividing powers, I'm subtracting. So 8 to the power of 19 divided by 8 to the power of 5. 19 take away 5 is 8 to the power of 14. Brilliant. Okay, and then I've wrote it as the form of 8 to the power of k. That is there now. Perfect. Super. And that's that question done. Add, subtract. Nice and easy, as long as you know what you're doing. So, pause now and have a little go at that one on the right-hand side. You'll probably have to do the bottom first. Pause now and have a go at that one. Okay, let's have a go at it together then. I think you're probably flying through these. You probably think to yourself, Mr. Adams, why are these so easy? Well, they do get a lot harder, trust me. Maybe not in today's lesson. So I've got 5 to the power of 11 divided by 5 to the power of, 3 times by 5 to the power of 4. So the first thing I'm going to do is I'm going to simplify the bottom, and then I'm going to do the subtraction next. So this is 5 to the power of 11 all over 5 to the power of 3 times by 5 to the power of 4 is 5 to the power of 7. Brilliant. Add them together. Add the powers together, that is. So 5 to the power of 11 divided by 5 to the power of 7, I subtract. So 11 take away 7 is 5 to the power of 4, and that's how they want it. They want it in 5 to the power of k, and in which case k is 4 in this case. Brilliant. Nice and straightforward. Should be flying now. So, check those answers. 8 to the power of 14, 5 to the power of 4. Absolutely super. Okay, let's step it up a little bit now. So, in fact, what I'm going to suggest you do is maybe pause and have a little go at that one yourself. See if you can do that one yourself. Okay, let's have a go at it together then. So I'm sure this is, I can always lose count. Example 13, I think it is. So I've got 3 to the power of 2, all to the power of 4, all over 3 to the 3. So I think you're probably fine with this. Do the top first, then do the subtraction. We know that when I've got brackets like this, I'm multiplying the powers. So 3 to the power of 2, all to the power of 4 means that I multiply. So this is going to be 3 to the power of 8, using that multiplication law, isn't it? Or divided by 3 to the power of 3. And then I'm going to subtract those. So this is going to be equal to 3 to the 3, divided by 3 to the 8, divided by 3 to the 3, which is 3 to the 5, like so. Super. I'm sure you will have smashed that. Let's just check that answer. 3 to the 5, absolutely brilliant. Super. So that's pretty much all of the basics of the laws of indices. And so if you're finding those easy, then well done. Good. So let's pause now. I'm going to put some questions on for you to have a little go at. So I'll make this big for you to have a little go at these. Remember to make sure you have a go at these, because remember the only way to learn maths is to do it. So I'll make that big. Pause now and have a little go at those. Super, I'm going to pop the answers on, so mark those in green. Mark them all in green. Brilliant, so thank you for watching this video on laws of indices. Remember to make sure you're having a go at the questions, because the only way to learn maths is to do it, and have a lovely day.